Today we're going to learn to solve systems of equations using the elimination method. And previously we had solved a system of equations, two equations like these two, using substitution. However, in the previous problem, when you look at the coefficients, so here we've got 2x and 3x, and then also 5x and negative 2y. In the previous situation, we had one equation with one variable that was easy to isolate because it didn't have a coefficient. That is, it had a coefficient of 1. And here we don't have that situation. So if we wanted to isolate a variable to use for substitution, such as the x in the first equation, we would have to divide by 2, and that would leave us with a fraction. 3 divided by 2 would give us 3/2 and so on. And so we want to use another method because none of our four terms is without a coefficient. So let's step through the procedure here. The first step says to write both equations in ax plus by equals c form. So this has been done for us. This is general form, and we have our x terms first, our y terms second, and then is equal to our constant on the right-hand side. The second step says choose which variable to eliminate. So we are going to either eliminate the x's or eliminate the y's, and that means we're trying to figure out how to make that variable drop out. And the way that we accomplish this is actually in step 3, to get the coefficients to have opposite sign and same amount. So for example, if I had a positive 4x and a negative 4x, when I add those together, the terms would drop out and then I'd have only y's. Now when we look at these coefficients, 2x and 5x, the only way we can get them to have the same amount would be to multiply and get a common multiple. So if, for example, I multiply the first equation by 5 and then the second equation by 2, I would have both of those terms to be 10x. However, I also want to have opposite sign, and so I would need to multiply one by a positive and the other by a negative so that I'd have one positive, one negative term. When we look at the y's, we can see positive 3y and negative 2y. Those terms do have opposite signs, so that condition is satisfied for us. And all we need to do is get them to have the same amount. And so the multiple, the least common multiple, would be 6 here. And in order to get a coefficient of positive 6 and negative 6, I would take my first equation and I would multiply it by a positive 2. And then I would take my second equation and multiply that by a positive 3. So 2 times positive 3y gives me 6y, but 3 times negative 2y gives us a negative 6y. And now because we've multiplied those equations, we have to multiply every term. So I'm going to rewrite the equations. So I get 2 times 2x is going to give me 4x, and then plus 6y is equal to, and then we have to remember to bring the 2 to the other side, 2 times 21 is going to give me 42. So that's the first equation. Now the second equation, we've got 3 times 5x is going to give me 15x, and then 3 times negative 2y gives me negative 6y is equal to, again remembering to bring it over, 3 times negative 14 is going to give me a negative 42. And now we'll go to step 4, which says add the two equations. So when we add up the left-hand side, we have 4x plus 5x is equal to 19x. But then the positive 6y and the negative 6y drop out. So the left-hand side is much simpler, and then positive 42 minus 42 is going to give us 0 over here. It says here in step 4, one variable should drop out, and that's exactly what happened. Our y's disappeared. So step 5 says solve for the remaining variable. We will isolate that x by dividing by 19. And we get 0 divided by 19 is equal to 0. So our first variable, x, is equal to 0. Now that we've got our x, we need to go back. We need to go back and solve this for y. So we will take this x equals 0 and plug it into either one of the original two equations, or if we wanted, we could use a modified equation. But the original equations are a little simpler, so I'm going to take 2 times 0 over here. So 2 times 0, which is our x, plus 3y is equal to 21. And simplifying that, we get 3y is equal to 21. And finally, solving for y, we divide by 3. And we get then that y is equal to 7. So that's our y value. And if we write this as an ordered pair, we've got x is 0 and y is equal to positive 7. Now, the last step is to check the solutions. This is optional, but we will go back and check this. So let's check the solution in each of the two equations. So in the first equation, 2x means 2 times 0 plus 3y, so that's 3 times 7. And is that equal to 21? And we can see this term, the 2 times 0 will drop out. 3 times 7 is equal to 21, and that checks. For our second equation, we're going to plug in. So we've got 5x, so that gives us 5 times 0 minus 2y, so that's minus 2 times our y value of 7 is equal to negative 14. And again, we don't know whether that's correct, so we're going to check it. We see 5 times 0 is still 0, but negative 14 is equal to negative 14, so this also checks and gives us a good solution.